Okay, this is Mike Thoming. I'm doing a quick demonstration of the work I've done with Java collections this week. So I've created a different Java class for each of them: list, set, map, tree, and a queue example. And I want to do a little more cleaning up and make this a little user-friendly, a little more user-friendly. But for now, I've just created each one as its own main class. So I'll just have to switch that as I go through each one. But I think it pretty well prompts the user to do everything. So you can see here when I ran this one, it's asking us to enter something into the list. So I'll just put my name, another name, and the next element, last element. Okay, so then it restates my list for me. Which of your previously entered items would you like to enter? I'm going to see if it can find the second element, and that's Heather. Yep, it is Heather. You can see is number 2 there. Which items would I like to change? Let's change number 3. That would be the Hannah element. We'll change that to Haley, lowercase h. So now it's Mike, Heather, and Haley, lowercase h. So what if I try to find Haley with a capital letter? It can't find it because it's got a capital H, so it's very literal in what it's looking for. Then I used an iterator method and restated the list again. So that shows a couple of things about the set. Actually, I'm going to run that again. One thing that is unique about the set that I didn't show there is that it will allow duplicate entries. So if I put Mike in twice, it will show it twice. And yep, third element is there, but it accepted a duplicate. That's true for a list, but it's not true for a set. So we're going to show that next. I'll go ahead and rename this. Let's see. I'm just going to crash that. Okay, so we'll rename this, get it out of the way. So now we'll go on to the list one. Oops, actually it's already there, isn't it? All right, so let's play that one. Number of items to be added to my list. So I'm going to add Mike again, and I'm going to add it a second time. See what it does there, and then I will add Heather. Oh wait, what's going on here? That is a list. Dang it! I meant to go to a set. That's what I meant to do. Sorry. Name that back. Save it. Set. Take that out. Now we will run it. Okay, so a set behaves a little bit differently. Once again, we'll add in my name, put it in a second time, put in Emily as a third one. Okay, so now my list looks like, oh, what? Just 2 elements. Well, that's because Mike was put in twice and it doesn't allow duplicates. So it just replaced the first instance that I entered with the second instance. And you'll also notice I put Mike in first and Emily in second, but now they're reordered. Why is that? Because sets are ordered lists. Okay, so now what would I like to search for here? This is also another literal string search, so it is case sensitive, I guess is what I'm saying. So we're going to search for Emily, and the Emily value was found. That's why that's true. So found in the set. That's what's a little different about a set, is the ordered nature of it and that it doesn't allow duplicates. Okay, so let's take that out. Save, and let's go do map. We'll activate that one. All right, so this one it was just a little more automated. I don't really have a lot of user interaction. But for a map, I had it add those for fruits. And I also you can see I put in literal or hard-coded key values for them. So there's a numerical value and the string value with each one. So then I had it list how many items were in the map, so there's 4, and then I had it show the key contents. And you can see again that matches what I hard-coded, the 3, 10, 27, and 12. And then I just had it list all of them with their keys. So that's what's special about a map, is that it not only includes the elements of the list, but it also has key values that are assigned by the code. And you can actually even have that assigned by the user if you code it the right way, but that's a little bit different than a set and a list. All right, so that's a map. Let's get that out of the way. Now we're going to we'll look at a tree. Okay. Activate that one, run it. Okay. All right. This one has a little user interaction, so what do I want to put in here? We'll put Mike in here again. We'll put Heather again, and then we'll add Emily. Oops. Okay. So again, that kind of went automated on us, but here's what it did. I entered these items in kind of reverse alphabetical order: Mike, then Heather, then Emily. You can see that when it restates my list back to me, it orders them in alphabetical order: Emily, Heather, Mike. And so that's one thing that's special about a tree. In this case, I did a tree set. So we saw before that I guess that was ordered, but anyway, it takes any if you use a tree along with a list or set that's not ordered, then it will order it. That's something special about a tree. So then I replaced that tree that I put in with names with all of these different numbers: 2, 4, 1, 6, 3, 7, 9, 5. And then I had it print the first and the last elements only, and then it says 1 and 9 as my results. Why is that? When 2 and 5 were the actual first and last entries. Well, because again, a tree orders them, not just alphabetically, but also numerically, if what you put in is numeric. So that's just another way to show that it does order the list. So then I try to enter a duplicate value, a 1, and it would not accept it. That's what this false statement is giving us. But if I add another element to the original list, it does accept that. That's what the true is saying there. So my final tree looks like this down here: 1, 2, 3, 4, 5, 6, 7, 9, and 11. Notice the 1 is not stated 2 times, just to reiterate that it didn't accept the duplicate, and it did accept the 11 because there was no such value already in the list. So that is a little bit of what a tree works like. All right, so let's get that one out of the way again, and we will go to a queue example here. Save that, go ahead and run it. All right, so queue has its own couple of special things. We're going to add more here. So Mike, Heather, Gage. So it lists my queue: Mike, Heather, Gage. The head element is Mike. That's what was put in first, and based on queue logic is also going to be the first one that gets removed when I add something new to the list. So that's actually what I did in my code, is I removed that. So now it does a poll function after that, and it shows Mike was removed and just Heather and Gage remain. So then the new head element is going to be Heather. So whenever I add or take any action on this queue, it's going to remove her because she was the next one in, and therefore will be the next one out. So once I do that, then the only thing remaining in that list is Gage. Now I want to go back and do some more inserts with this, just to show not only the removal of the oldest element, but then adding the new one in and how the list reorders, or how it shows, the newest element in order sequence with the other ones that were added earlier. Okay, so that's all of the examples that I've got so far. Looking forward to any feedback you can offer, and ready to do a little more work on this. Thanks.